A vector. A vector is a quantity with both magnitude and direction. Magnitude means size, and it has got also direction, so there is somewhere where it is going. But when you're talking of course, we also have a scalar. Now, a scalar or a scalar, it just has magnitude. It has got no direction. Examples that we can give is, for scalars, I can give mass, I can give volume. Apart from this, uh, we can give currency like money. We can give temperature. There is no direction. If they measure your temperature, they will not tell you up or down. You can talk of speed, you can talk of distance. All these are scalars. But when you come to vectors, you've got acceleration, it has got a direction. You've got velocity, there's a direction. You've got displacement, you've got pressure, you've got weight, you've got gravity, you've got a force. All those have got directions. Now, I want to explain one scalar and one vector. They're almost the same but different, so we know their difference. If let's say this is point A and then this is point B, I'm going to give an example of my place. Say this is Solwezi, for some of you who are in Solwezi and then you want to go to school in Lusaka. So the direct distance between these 2 points, direct distance between these 2 points, this is what we call displacement. Now, when you're going from Solwezi to Lusaka, you don't just go straight. Why? Because there are mountains, there are big rivers in the way, and there are big rocks. So you might travel to Chingola in the Copper Belt, Kitweka, Wendola, those places. You'll go in different places, and then you are going to reach Solwezi. The actual path that you are going to take for you to move from point A to point B, that is what we call distance. And for distance, we don't care the direction. You can go, you come, you go, you come until you reach the final end. So displacement, we say it is the shortest distance between 2 points. So from here, these are also exam questions. Distance, the comparison between distance and displacement. Distance is always greater than displacement. At times distance can be the same as displacement, but there is no time when displacement is greater than distance. So displacement is the shortest distance between 2 points, but distance is the actual path. For example, you can be here and then your friend is here. You can just go straight. Maybe this is where the road is. You can just go straight. That will be your distance and it will be your displacement. Immediately you put an arrow showing direction, then it is no longer distance, it is displacement, because displacement is a vector while distance is a scalar, because you're not interested in direction, you're only interested in the length between 2 points. So at times distance can be the same as displacement. In the case of a straight road, this is the path that you are going to take yourself, and that is the same direction you are going to go. So it is distance and displacement. In that case, displacement and distance, they are equal, but in this case distance is greater than displacement. So same with a speed and velocity. Speed is distance over time, but velocity is displacement over time. But we actually use them interchangeably, because in physics you're going to take that most of the things distance is going to be the same as displacement. That's why if they ask for distance, you are going to find, or I mean, if they ask for speed, it's the same as velocity, and the units are all the same, meters per second, because we take them basically for the same thing. Now, when you are working out vectors, you need to make sure you know about components of vectors. I'm going to draw an x or y plane. If you've got this as the x or y plane, this is the x-axis and we have got the y-axis here. Imagine you have got a point here which is, let's say there is y here and then there is x here. This is point A. So if you want to write point A as a point, it is going to be x comma y. Remember at grade 12, this is how we represent points. So you can represent A as a vector. Now you're going to draw a line starting from the very middle, which is the point 0 comma 0, and then you're going to join it as a straight line like that. So in this case, since it's a vector, I'm going to put direction. I'll show it like that. Therefore, I can write A as a vector. I'm going to say it is moving from the point O to the point A. And then I'm going to put arrows on top like that, just like we did at grade 12. So the vector OA, I can write it as the column vector. We're going to put X on top and then Y down. I can as well write this vector with a small a. I'll put a bar down. I'll say X, Y. This as a column vector. Apart from a column vector, I can write it in position form. I can say vector A is equal to X. The coordinate that is related to X, I'm going to put I. And then plus the coordinate that is related to Y, I'm going to put J. At times we're going to have a vector in 3 dimensions, for example x, comma y, comma z. So the coordinate related to z we always put k. So we can write a vector in this form: I, j, k. Whenever you see I, it means something is related to x. Whenever you see j, it means something is related to y. Whenever you see k, something is related to the z axis. So you can also represent a vector like that. Apart from this form, we can also represent a vector as I can write x, comma y, comma z, but I'll not even put these commas. I'll just put spaces x, y, z. Then I'm going to put this. This is also a vector. This is meaning x coordinate, y coordinate, and then z coordinate. So these are always in which we represent vectors. Now, if you can look at this, all of these vectors have got the x component and the y component. In other words, they've got the x, y, the x value, and the y value. So we can break vectors in those forms. You can break vectors and find the x component and their y component. This comes from the simple Pythagoras theorem that we can remember. If we've got something like this, look at this triangle. This is a right angled triangle. So this is y and this is x. Since this is a right angled triangle, yes, yes, please. On what? Oh, there's a lot of background noise. Just take it as if it's not there, or it's too much. All right. So now look at what is here. This is a right angled triangle. I can put 90 degrees there, but not necessary. So if this vector has got, let's say, the x component, the x value here is, let's say, a 2, and then the y value up to that point, so I can put here as a 2, and then the y value up to that point is a 3. What does this mean? I can also write this, I can write it like that. The distance from this point to this point, this is what we can see as a 2. And then the distance 3 here is from here up to the maximum there. That is what we are seeing as a 3. Now the question is, how can we find the hypotenuse? Who can help us? How can we find the hypotenuse here? From the Pythagoras theorem. So the hypotenuse is the longest side. Let me call it r. We call it r because it is the resultant of these two vectors. So therefore, r, you find it by getting the x component, you square it, you get the y component, you square it, and then the answer that you get, you square root. So therefore, r is going to be 2 squared plus 3 squared and then square root. So that is how we find the resultant of a vector. Does that make sense? From by just from the Pythagoras theorem. So if you've got a question, please you can go on. I've seen some hands, Casey, Peggy. Okay, so if there's a question, just be free to ask. Now that we've seen this, let me write it again because we're about to do something interesting. So we are looking at components of a vector, or breaking a vector into its components. Whenever they say break this vector into its component, means find its x value and its y value. Okay, so this is our vector which is put here, and I'm going to label it as vector A. Let's say this vector A has got a magnitude of 20 newtons. So this is a force, and it has got that magnitude. The magnitude is simply the size. It is 20 newtons, or I could have put it in meters as 20 meters. Now when we find the angle relative from the positive x-axis, that is what we call the direction of a vector. So let's say this vector is making 30 degrees. So we say that this vector A has got a magnitude of 20 degrees, and it has got 30 degrees direction. So sorry, it has got a magnitude of 20 newtons and a direction of 30 degrees. Now I can find the components of this vector. What do I mean by components? I can find the x and y value that made up this vector. So I can break it like this. So we have seen that this is 20 newtons, and then the angle which is called the direction of the vector here is 30 degrees. So if you see this side is going up. This is called the y component. This side is down, like it's parallel to the x-axis. This is called the x component. So from just a simple thing that you can remember, SOHCAHTOA. From the SOHCAHTOA, we say that sine, in this case the angle you can see here is 30. So sine of the angle, I'll say theta, is given by opposite. Now what is opposite in this case? Opposite is y over hypotenuse. What is the hypotenuse? I'm going to call this as a resultant error, so it will be y over r. And then when you come to this one, that means cosine of the angle theta is given as adjacent. Adjacent is what? X. Hypotenuse, here the hypotenuse is still r, as you can see. So let me make y substitute the formula. I'm going to multiply these two. So y is given by r sine theta, and then x is going to be given by r cos theta. So these are formulas that you need to know by heart. When you want to find the x component of the vector, just get that magnitude of the vector and then multiply by the cosine of the angle. And then when you want the y component of a vector, just multiply the magnitude of that vector with the sine of the angle, and then we remain with tan. So tan theta is given by opposite. Now opposite, we can see opposite side is this one where you are looking at the angle. So the opposite side of the angle, that is y over adjacent. The adjacent side is the one which is next to the angle, that is x. So this gives you what we call the direction of a vector. That is how you find the direction of a vector. So the direction of a vector is given if they ask you to find the direction of a vector. In other words, they are asking you what is the angle of that vector. So now that we know the formulas, remember y component is always r sin theta, x component is always r cos theta. And then we also have the addition of vector. Let's see a question. Vector A has a magnitude of 40 meters and makes, let's say, from the negative x-axis in the clockwise direction. Break, find the component. Okay, so here is the question. We've got a vector here that has got a magnitude of 40 degrees and makes 20 degrees from the negative x-axis in the clockwise direction. Now I want to find the components of A. Now, before you get to answer this question, you need to interpret this information. I've told you of the x-axis. So we're going to draw the x or y plane here. We know the positive x is here. The positive y is going on top. Going is the negative y, and then going is the negative x. Now look at this one. The first thing that we're going to look at is the direction. It is 20 degrees from the negative x-axis. Where is negative x-axis? Negative x-axis is portion. This is the negative y, so we're interested in the negative. And then on the negative x, what is, where is it going? Is it going in the clockwise or anti-clockwise? So it is in the clockwise direction. Which direction is clockwise? Is it this direction or this direction? Let me give a more choice, A or B. I want people to respond. Which one is clockwise? Is it A or B? Okay, it's A. Good. Meaning that this vector, now this is the negative x-axis, and from the negative x-axis we are making 20 degrees in the clockwise, meaning in direction, and we are going to make 20 degrees. So this is 20 degrees. That is where the vector is. This is vector magnitude is 40 meters. So we have shown the diagrammatic representation. If they said this vector was 20 degrees in the anti-clockwise, then it would have come here, because anti-clockwise is going down, so the degrees would have been here. So this is why we need to be very more attentive to these questions. Now that we've found this, we can now break this vector into components. Now before you break components, please, I want to emphasize this. Always make sure that you find the angle that is relative and clockwise direction. You should always start from this point and then going in this direction to find where the vector is. So the vector is here, there. Now you need to find this angle that it is making. Who can tell us how can we find this angle from where x is to where the vector is? How can we find that angle? How can we find the angle? That is it. Okay, good. Very good. So it will be 180 minus 20, since this is a straight line. Therefore, this angle is going to be 160 degrees. Therefore, the components. So, me, I would advise you to write it in this way. First, we're going to put vector, and then you're going to put x component, and then you're going to put y component. If you want, you can put the word component there. So here we've got vector. And then how do you find the x component? We're going to say I'll put a comma small x here. The x component is given by, remember we said this magnitude, which is A itself, and then cos theta. And then the y component will say y. That is given by the magnitude of A and then sine theta. So to find the magnitude of 40, and then cos the angle starting from the positive x-axis in the anti-clockwise direction, that is 160. And then to find ay, it will be 40 sin 160. If you have get a calculator, you can just punch that. So 40 sin 160, that is giving me 13. Oh, sorry, I've started with sin, so 40 sin has given me 13.7. And then 40 cos 160, that has given me negative 37.
The calculator is in degrees because we are using degrees. If you just let the calculator in radians, you automatically count that you've lost some marks because it will give you something else. Okay, and if you can see, this answer makes so much sense. Why? You've seen that the x component you found is, yes, yes, please. Okay, so I said, can you just say it again? Y is equal to? No one is speaking. So we said y is equal to r sine theta, and then x is equal to r cos theta. So this y is basically representing any y component. So if you are talking about vector b, I'll just put b here. It becomes by to mean that the y component of b. And the r, which is the resultant, I can use b here because I'm talking about the resultant for the vector b. And then here for b, I'll put b. It becomes bx. And then this r will become b because I'm talking about the magnitude of b. So if you set the x component to found negative, and this Go on. Kindly repeat what you've said. Yes, r sine theta. And then
for x is r cos theta. And then what's your question? Okay, so look at this, the x component here. This is the x component. We have used cos, which is here. X component, you always use cos. This is the y component, we've used the sine. So it's not something that you're just supposed to master. That is why I've given you that deriving, so that perhaps you forget at one point you can derive it. Perhaps you mix which one you're supposed to use for which one. Does it make sense now? Or maybe there's still a question. Okay, good.
For this solving, is it always going to be cos and sine, or maybe there are scenarios where they have to use tan?
So it's always cosine sine. Tan is only used to find the direction. I'm going to give an example of that. So of course we are not restricted that x component is always using cos, but I want you to make sure that we used to forget in the exam these things. That's why sticking to cos is better for x component. So let's say we've been given a vector which is equal to, let's say, 30 newtons. Let me not even give the newtons. Let me just give the direction. A vector has components. Let's say x is equal to negative 20 newtons and y is equal to 30 newtons. So the question is find its magnitude and direction. So if we've been given the components, how do we find the magnitude and the direction of a vector? So to be able to find the magnitude and the direction, remember we said how do you find the magnitude?